Hey there, and welcome. For as long as we've been human, we've looked up at the stars and wondered. But what used to be the stuff of myth and legend is now right on the brink of becoming the stuff of pure discovery. We are talking about a new generation of telescopes so powerful they're going to completely change the game and maybe, just maybe, answer some of our oldest questions.
So how do you even begin to solve the universe's biggest mysteries? The big ones. Where did everything come from? Are we the only ones out here? Well, the key isn't some magic formula. It's all about being able to see farther, clearer, and deeper than we ever have before. And it all starts with observational astronomy.
Think of observational astronomy as our collective window to the cosmos. It's the method we use to peer out into that incredible vastness, to look beyond our own little world and try to make sense of it all.
Okay, so what is it exactly? Well, simply put, it's the science of gathering data from space. And listen, this is way more than just looking through an eyepiece. It's about capturing everything the universe is throwing at us, from the visible light we can see to invisible signals like infrared and radio waves. We use all of it to decode the secrets of planets, galaxies, and yeah, even black holes.
And of course, that brings us to the amazing tools that make this all happen. Telescopes. But have you ever stopped to think about how they actually see the universe? Because as it turns out, there's more than one way to look at the stars.
So there are a few main ways of seeing. You've got your optical telescopes, which work a lot like our own eyes. They just gather up all the visible light they can to make a picture. Then you have radio telescopes, which are totally different. They pick up on invisible radio waves, showing us cosmic events that are completely hidden from our normal vision. But there's a third way of seeing, and it's a real game changer.
I'm talking about infrared. Telescopes like the James Webb are designed to be what you might call dust piercers. They can literally see right through those massive, thick clouds of cosmic gas and dust. And you know what's hiding in there? New stars and planets being born. They give us a front row seat inside the universe's nurseries.
Which brings us to the heroes of this story, the next generation of super telescopes. These are the machines that are absolutely poised to revolutionize, everything we think we know about the universe.
So let's meet these new titans of the cosmos. We've got the James Webb, which is already out there in space doing incredible work. And hot on its heels are three giants being built on the ground: the Extremely Large Telescope, or ELT, the Giant Magellan Telescope, GMT, and the 30-meter telescope, TMT. Now, they might sound similar, but each one is a specialist with a very specific mission, from taking actual photos of exoplanets to finally figuring out what dark matter actually is.
Just to give you a sense of the scale we're talking about, the main mirror on the ELT will be 39 meters across. That is almost half the length of a football field. And a mirror that big isn't just for show, it's about sensitivity. It can collect more light than pretty much every other major telescope on Earth combined. That means it can see the faintest, most ancient objects from the very dawn of time.
And what about clarity? How sharp will the pictures be? Well, the Giant Magellan Telescope is going to deliver images that are 10 times sharper than the Hubble Space Telescope. Just think about that. Remember all those iconic, jaw-dropping photos from Hubble? Now imagine them with 10 times more detail. That is the kind of incredible leap forward we're about to witness.
And what's so cool is that this is a truly global effort. The 30-meter telescope, for example, is this amazing partnership between nations all over the world. And India is a major partner in building it and in the science it's going to do. Its whole mission is to give us these mind-blowing views of everything from stars being born to the supermassive black holes at the center of galaxies.
Okay, so we're building these incredible, massive, world-changing tools. But the big question is, why? What are we actually hoping to find? What are the great cosmic mysteries that these new eyes will finally help us solve?
Well, the scientific to-do list is just breathtaking. Right at the top, searching for biosignatures. These are basically chemical fingerprints in the atmospheres of distant planets, things like oxygen or methane, that could be a sign of life. The ELT and GMT are so powerful, they won't just detect these planets. They're designed to take the first ever direct photos of them. We're also going to use James Webb and the TMT to see the universe's first galaxies switching on. And the GMT will help us map the invisible structure of the universe to finally get a grip on dark matter and dark energy.
So, when you pull all of these new abilities together, what does it really mean for us? It means our entire perspective on the universe and, our place in it is about to fundamentally change. We are standing right here, today,
at the very beginning of a new era of discovery. The things we find over the next 10 to 20 years, they're not just going to be little footnotes in science books. They're going to rewrite the books entirely.
This isn't about taking tiny little steps forward. We're talking about a revolutionary leap in what we can see and what we can understand. We are, quite literally, about to see the universe with completely new eyes.
And all of this leaves us with one final, incredibly exciting thought. When these new eyes finally do open, and we get to peer into the deepest, darkest corners of the cosmos, what are we going to see? And maybe, even more important, what complete surprises are just waiting out there